Hello everybody, this is going to be the very first lesson, 1-1, and this lesson is about domain, range, and end behavior. So the do now, or the warm-up that I had you do at the beginning of class, is to basically find x equals 0 on the number line. Now that is basically just a point, so very basic right there. Now, what are the symbols for the following? Less than, if you can't, or if you have trouble remembering, you can see that the less than looks like an L. So, in order to remember what the symbol for less than looks like, just think of it as an L, and it's basically the symbol right here. Greater than is just basically the other way. Less than or equal to, well, you have that L shape, and then you have the line underneath, and greater than or equal to is basically facing the other side. Okay, so very important to remember these symbols. Now, another thing I had you do is graph this right here. X is less than 0. That's basically reading this. X is less than 0. Now, here's 0 right here. Now, think of it this way. What number is going to be less than 0? Well, it's basically any negative number. So, if you were to graph this, it's going to be all the negative numbers, and you realize that you can just keep on going and going, and really, in order to represent that, you just basically draw an arrow. So here is the shading for x is less than 0. Okay, here we have x is greater than 0. So here we start at 0. Now think of it this way. X is greater than 0. Well, what number is greater than 0? Because x is just a variable. A variable is basically any number that fits this fact. So what number is greater than 0? It's basically 1, 2, 3, 4, 5, and you realize that you can just keep on going because all these numbers are greater than 0, and so you actually never stop, and you just basically draw that arrow. So that's how you graph those two. Okay, so I gave you guys a worksheet. This is basically it right here. So in this worksheet, I gave you something so that you can use, something that we'll definitely use repeatedly. So let me draw. So this is what you had on your paper. Okay, what we have here is an open circle. Now, every time you have an open circle, you're either going to use less than or greater than, and you're always going to have parentheses as part of your interval notation. We're going to see specifically what I mean in just a minute. Here, this is an open circle. This below must be a closed circle. And for closed circles, you're always using less than or equal to or greater than or equal to. And in interval notation, you'll be using square brackets or just brackets. Okay, so what do I mean by all of this right here? Well, let's say, for example, we had the interval from -5 all the way to 3. So what I have here on this graph is going to be an interval. Now, the first thing I want to do is find the inequality form to represent this interval. So what I want to do is find the two numbers the lowest number in the interval. So the lowest number is negative 5. Negative 5 is going to go on the left. And the highest number, the largest number in my interval is 3. 3 is going to go on the right for the largest number. And this is the smallest number. Now, so one thing that when you're working with number lines on an interval on a number line, your variable is most commonly going to be x. So you always have x in the middle. Now this is where we can use this information here. Because we have an open circle here, remember, open circles we're always going to use either less than or greater than. So in this case, we're actually going to use less than. And when we look at 3, there's a closed circle. So for a closed circle, we have to use less than or equal to. So finally, this is the inequality notation for the interval. Now, you may be asking, well, why didn't I use, instead of using less than, why didn't I use greater than or equal to? Well, the reason I use less than is because, well, this is an open circle, so I can't have equals to because of our chart here. Open circle, you always have to use either less than or greater than. Now, if you take a look at just this right here, x is greater than x. This is saying that x is larger than negative 5. So if you look at the interval, what is going to be larger than negative 5? Well, it's basically negative 4, negative 3, negative 2, negative 1. And so if I had it to where negative 5 is larger than x, well, what values are smaller than negative 5? Then it would be negative 6, negative 7, negative 8, and you'd basically be going this way. So this, which is not where the interval is at. The interval is at between negative 5 and 3, so we have to use less than. Same thing with this one. We have to use less than or equal to because of this closed circle, so we have to use that line underneath. Okay, set notation. Set notation, you're going to use a curly brace. You're always going to, since we're on the number line, we're going to be using the variable x and closed curly brace. So this is always going to be the setup. Now, in order to complete the set notation, all you have to do is basically take this and put it inside here. So we have negative 5 less than x less than or equal to 3. That's all there is to it. Okay, and finally, interval notation. For interval notation, you want to write your smallest number first in your interval. So we have negative 5 and then comma, and then your largest number, which is in this case 3. Now here's where you have to go back to our chart. Since this is an open circle means that we have to use parentheses. So since we have an open circle by negative 5, we have to use parentheses right there. Now, since we have a closed circle at 3, closed circle means that you always have to use a square bracket. So that means at 3, we have to use a square bracket. And so here we have the interval notation. Okay, so what I had you guys do after I showed you that example, I had you go to page 5 and do both of these two examples here. So page 5, you had to do A. Now after that, I showed you a different example. So this different example, I had a closed circle at 1, and then I shaded everything to the right and had an arrow at the end. And so what we want to do with this is also find the inequality notation, set notation, and interval notation. So for inequality, remember, since this is a number line, you're always going to have x in the middle. Here, you can have your smallest value, which in this case is 1. Your largest value is pretty interesting. Notice that the arrow says that it just keeps on going and going and going. So, in this case, your largest value is going to be infinity. Okay, now notice that at 1, I have a closed circle. So for closed circle, I have to use this symbol right here, less than or equal to. So it's going to be 1 is less than or equal to x. But what symbol am I going to use right next to the infinity? Well, for this, here's a special rule. Whenever you have infinity, always use less than or greater than and parentheses. So this is a rule that we're always going to follow. In this case, x is going to be less than infinity. So the reason we don't use less than or equal to is because this equal to basically means that you have a number that equals infinity, which does not make any sense. So this is why we have to use this symbol. Now, there are two other ways that you can write this inequality. You can basically just write this. So we can have 1 is less than or equal to x. Or you can flip this around and say that x is greater than or equal to 1. So each of these forms is the correct form for inequality. Okay, set notation, remember, we're always going to have a curly brace, vertical line, and by the way you read this is x such that. This line right here actually means such that. Okay, so x, now remember from our last example, what goes inside this space is basically the inequality. So we can take, since all of these three are the same, we can basically pick one of these to go inside. So I'm just going to go ahead and pick this to go inside, and that gives us our set notation. Okay, finally, interval notation. Remember, interval notation, you have to write your smallest value first, comma, and then your largest value, which in this case is infinity. Since we have a closed circle at 1, remember, closed circle means that we're going to use a square bracket. So there's square bracket right there. And remember this rule, infinity always use less than or greater than and parentheses. So you're always using parentheses with interval notation for infinity. It's never going to be the case where you use a square bracket. That is wrong. So here is our final answer for interval notation, 1, comma, infinity. Okay. So there's something important that I want to point out here. So looking at the similar examples that we just worked out, notice that here we start at 0, and then the graph just keeps on going and going to infinity. Now there's actually a way you can write that. X goes to infinity. That's basically what I'm saying right here. X goes to infinity. We also had a graph where you actually go to to the left, and you keep on going to negative, negative, and negative numbers. So basically, instead of going to infinity, you're going to negative infinity. So just a way to simplify this, here you're starting at 0 and then you're going to the right. So basically this notation right here says that you're going to the right. That's just a really simple way of simplifying what this is saying right here. Here, this is basically saying that you're going to the left. So x goes to negative infinity. Alright, so the reason I point these out is because we want to talk about end behavior. Now, notice that we don't have just our number line. Well, here's basically the number line right here, the one that we've been looking at basically. But instead of calling it the number line, we call it the x-axis. And this axis right here is called the y-axis. Now, it also has another name, which we can call it as f of x. So you can call it y or you can call it f of x, either way. Now, take a look at this graph. This is a line right here. This here is a line. Now, I want to ask you this question. As we're going to the right, as I'm going to the right, is the graph going up or down? Well, you can clearly see as you're going to the right, this graph is moving up. So this is what we mean by end behavior. Now, you wouldn't write it like this. As you go to the right, the graph goes up. This is a very simple way of just getting the basic idea for end behavior, but we have to write it in mathematical notation. So remember, when we talk about right, we have to use this notation. So as x goes to infinity, so this right here, this is basically saying that you're going to the right. But how do we write that the graph goes up? Well, the y-axis is talking about going up or down. So instead of using the variable x, which is for left and right, to talk about up and down, you're using the variable y. And so if we're going up, we're talking about values that are positive and they get larger and larger. So we're talking about positive infinity. So here is the end behavior for my graph. As x goes to infinity, y goes to infinity. This is basically saying as you go to the right, the graph goes up. That's it. Okay. So now we want to figure out how is the graph going when we go to the left. So as we go to the left, which way is the graph going, up or down? Well, when we go to the left, you can see that the graph is going down. So the graph goes down. Well, again, we have to write this in mathematical notation just like this. So remember, the notation for going to the left is x goes to negative infinity. So x goes to negative infinity. And in order to represent down, that's we have to use the variable y. And since we're going down on the y-axis, we're talking about negative values. And so in this case, we're talking about y going to negative infinity. So there we go. This right here basically says that as you go to the left, the graph goes down. And so we have described the end behavior of this graph, basically. Okay, so what I want you to do is actually do the same thing for this one. I want you to give me the end behavior for this graph. So first of all, as we go to the right, which way is the graph going? And as we go to the left, which way is the graph going? I'll leave it up to you to come up with the end behavior for that one. So you have to have something like this. Alright, finally we get to domain and range. So domain, first thing we want to do is find the domain for this right here. Now, one very simple trick that I like to use is the use of elevator doors. So let's say that I have an elevator doors on both sides. Now these elevators close horizontally. So they close horizontally and they open up as well. Now, to find the domain, basically what we have to do is concentrate on the x-axis. You're only looking at the x-axis. So this is the original question. It's going to give you both axes, but when you're looking for the domain, you're looking at just the x-axis. Now, these elevator doors are special. They only open up so that it just lets the graph through just barely. So if we open up this elevator door, it's going to stop wherever the graph stops. So here. And this other one is going to open up to where it just stops, which is here. So notice the number at where the elevator door stop. That is going to give us where the domain is at. So our two values in our interval for the domain are going to be 6, -6, and 7. So first of all, we want to put this in interval notation. So remember, interval notation, in the middle you always have x, and on the left side you always have your smallest value, which is in this case -6, and then your largest value goes on the right, which is 7. Now, remember, in order to figure out what symbol you're going to use, are you going to use less than or greater than, less than or equal to, or greater than or equal to? You have to look if you have closed circles or open circles. In this case, we have a closed circle on both sides, so that means that I'm going to have this symbol right here. So going back to our cheat sheet, closed circles means that you're going to have less than or equal to or greater than or equal to. So it has to be one of these. So it's going to have to be less than or equal to for both of them. There we go. That is the domain for this graph right here. Okay, so we want to put it into set notation as well. Set notation, remember, is basically where you use the curly braces, x, and then the vertical line, which means such that, and you basically put this interval inside. So -6 is less than or equal to x, less than or equal to 7. Done. And finally, so this is the inequality form, the interval notation for this. So this is inequality, just to make it clear, inequality. This is set notation, and finally interval notation. We're going to write our smallest value in our interval, which is -6, and then comma, the largest value. Now, since we have the closed circles on both ends, remember, going back to our sheet, closed circle means that you're going to use square brackets for interval notation. So we have closed bracket on the left side and closed bracket on the right side. There. Done. So that is how you find the domain. You have to use what I like to use this method because it really helps visually. Just basically you have elevator doors that open up just enough so that the graph can go through. And wherever the elevator stops on the x-axis, those values that it stops at gives you your smallest and largest values for the interval. Okay, now notice we have to find not just the domain, but we also have to find the range. So for the domain we have to look at the x-axis. For the range we actually look at the y-axis. And in this case I just took away the x-axis so it doesn't distract you, because we just need to look at the y-axis to find the range. So for the domain, let me just clarify. You use horizontal elevator doors, and for the range there are actually elevator doors that open vertically. So let me go ahead and draw my elevator doors. Here's one and here's the other one. So vertical elevator doors do exist. So let's go ahead and open these elevator doors just enough so that the function barely fits through. So here and here. And this is going to give us the largest and smallest values for the range. So here my smallest value is -7, which is going to go on the left side, and my largest value is 5. Okay, now because we're talking about the range, we're no longer using x, but we're talking about the y, the variable y. So instead of having x, you're going to have y for the range. Now everything is pretty much basically the same, since we have closed circle on both sides. So by -7 we have a closed circle. That means we have to use less than or equal to. Going back to my chart here, every time you have a closed circle you have to use less than or equal to or greater than or equal to, and then you have to use square brackets. Alright, and notice that we have a closed circle by 5, so we have to use less than or equal to. So this is the inequality form. Set notation, basically the same thing. Remember, we're no longer using x as our variable, we're using y. So this time we have curly braces y, we still have that vertical line, and basically you take this inequality and put it inside, and so this is what we have here now. This is our interval, or our set notation. And finally, interval notation, we're going to put our smallest value on the left and our largest value on the right, separated by a comma. Since both ends contain a closed circle, so at -7 we use a parentheses because we have not parentheses. Maybe I need to check back on my chart here. If you have a closed circle, you have to use square brackets. So good thing I have that chart right there to remind me. You have to use square brackets because we have a closed circle here, and we also have a closed circle by 5, and so there is our interval notation. So that's basically how you find the domain and range. Now So this was an example where we had a line that begins at a point and ends at a point. So notice that this line does not keep on going, it stops at 2 points. Now, what if we had a graph that doesn't stop but goes infinitely long into some direction? So again, we want to looking at this graph, we want to find the domain and we want to find the range. So remember, the domain, we're using horizontal elevator doors. Okay, so let's go ahead and draw our doors. Horizontal elevator doors. There we go. Let's close them. Now, here's the important part. Let's open the elevator doors just enough so that the function can pass through. Okay. Keep on going and going. And you might say, well, okay, I can stop here, and then on the other side, I can stop here, and the elevator, and then the graph can go through the elevator doors. But these arrows right here basically mean that the graph keeps on going and going and going and going, and on the other side it keeps on going and going, and it actually keeps on going until it never stops. And so these elevator doors keep on opening and opening, and so if these elevator doors keep on opening and opening, what is going to be my smallest and largest values? Since these elevator doors are actually never going to stop, my smallest value is actually going to be negative infinity, and my largest value is going to be infinity. Now, because we're talking about domain, you have to use the variable x. Now, remember the rules about infinity. Here's my rule. Infinity, always use less than or greater than in parentheses. So that means that because I have infinity on both sides, I have to use less than. Okay. So we're actually finally done with the inequality form. So this is the inequality form right here. Now, for set notation, again, we can go ahead and set it up properly. So we have negative infinity, less than x, and remember what goes inside is basically our inequality. Now, because we actually have negative infinity and infinity of both sides, there's basically an easier way of writing the set notation, and that's basically this right here. So x is the element of the real numbers. So let me read this line by line. X such that x is an element of the real numbers. So this right here is the same thing as this. So either one is the acceptable answer. And the only reason we can use this right here is because we have infinity on one side and then negative infinity as our smallest value. So infinity as our largest value and negative infinity as our smallest value. And finally, for interval notation, we're going to write our smallest value, comma, and then our largest value. And remember, our rule for infinity, always use less than or greater than, and always use parentheses. So that means that since I have infinity on both sides, I'm going to use parentheses, and that is my interval notation. Okay, so we are done with the domain. Domain is done. That means we need to look at the range now. Now for the range, we use vertical elevator doors. So here are my vertical elevator doors. Now again, we want to open these elevator doors just enough so that the graph squeezes through. So opening the bottom one, you can see that we can stop exactly right here just so that the graph squeezes in through. So this actually gives us our smallest value. And remember, we're just looking at the y-axis. We're looking at just the y-axis. So what value on the y-axis is this elevator, the bottom elevator door, stopping at? That is going to be 0. So 0 is going to be our smallest value. And remember, we're using y in the middle because we're talking about the range. Now, let's look at the largest value now. Where is this top elevator door going to stop at just so that the graph squeezes through? So here we see the arrows, and these arrows basically mean that the graph keeps on going up and up and up and up and up, and it never stops. And so another way of writing that is that the largest value is going to be infinity. Now, just as the domain, when we have infinity, we have to use less than, so we have less than right there. But notice the graph is touching y equals 0. So this, you can't see it because this is basically a solid line, but really there is a solid point right at y equals 0 because the graph goes through that point. So because it goes to that point, for a solid or closed dot, remember going back to our chart, closed dot, you're going to use less than or equal to. So here we have to use less than or equal to. Okay. Now, because we have infinity, there are two other different ways we can write this. We can write it as 0 is less than or equal to y, or y is greater than or equal to 0. So any of these three forms can be used as your inequality. They're all the same. Set notation. So remember, because we're talking about the range, we're using y, and then the vertical line, which means such that. And basically you can pick one of these inequalities to go inside for the set notation. So I'm just going to keep it simple. I'm going to use this one, and that's the set notation. And finally, interval notation. Interval notation, you're going to take your smallest value, which is 0, and then your largest value, put it on the right, which is infinity, and separate them by a comma. Now, because we have the less than or equal to next to the 0, remember looking back at our chart, because we have less than or equal to, that means that we're going to use a square bracket. So square bracket by the 0. And remember, the rule for infinity, always use less than or greater than and parentheses. So for infinity, we have parentheses right there. Alright, so that is it for domain and range. We found the domain and range, inequality form, set notation, and interval notation. And finally, end behavior. So these should look familiar. Remember, I really simplified these. This notation here means that you're going to the right. This notation here means that you're going to the left. So let's go ahead and write those right there. So positive infinity means that you're going to the right. X goes to negative infinity means that you're going to the left. So what do we have to add to this? Well, we basically have to find where if we're going up or down on the graph. So looking at this, if as we're going to the right on the graph, so we're going to the right, you can see that the graph is going up. So the further you move to the right, the graph keeps on going up. So we're going up. But how do we write that in mathematical form? So remember, for up and down, we have to use y. And since we're going up, we're talking about positive values, which in this case is positive at infinity. Okay. Now, as we're going to the left, which way is the graph going as we move to the left? Well, as we're going to the left, you can see that the graph is also going up. So the graph is still going up as we go to the left. So we basically write y goes to positive infinity again. Alright, so after we get done through these, what I basically want you to do, start working on, is questions number 1 through 8. Alright, thank you for watching. 1 through 8, this is going to be page, let me make sure I give you the correct one. Oh, this is what I mean. Numbers 1 through 8 on page, let's see what page this is, page 12. So now you should have enough knowledge to answer questions 1 through 8 on page 12. Alright, thank you for watching.